Good morning, London. Usually I have like a little time to set up my laptop, but it's already set up, so I guess we're just gonna go from here, huh? Hi, I'm Ken Wheeler. It's Ken_Wheeler on Twitter. That's not me. That came with Keynote. He looks nice, so I just kept it. And yeah, so my talk is Performance is Magic, and I guess we could start with what is magic? And I'm very sorry. I know this is the land of Mary Poppins and Hogwarts and what have you, but it is not real. Sorry. Magic, I guess defined by whatever dictionary on Google came up first, is illusions as entertainment by the use of sleight of hand. Sleight of hand, which is basically trickery. And it's absolutely everywhere in UI programming. As you can see in this incredibly unmaintained carousel, right? It looks like you can go infinite, go back around, it's all smooth, right? You say, how does that work? And, it is just trickery, right? When you come here and you take the overflow off, that's what, just appending ones to the other side. Just a collection of filthy, rotten tricks. So, filthy, rotten tricks as they relate to performance. Normally when you have a performance talk, what you're seeing are suggestions for things like service workers, right? You're lazy loading images, code splitting, all that stuff. And I guess a lot of the focus that I see is on load time performance, right? Everybody wants their site to load up on bad networks or what have you, network conditions that are less than favorable. And the big metric that I guess they always focus on is time to interactive here. So you have your little feedback. So what is interactive? Interactivity is when your main thread has gone idle post-loading, and it's the point at which users can actually use your app. So instead of talking about the load stuff, which there's a lot of prescriptive stuff you can do, today I'm going to talk about runtime performance. Once you become interactive, staying there. Sorry, no drum machines today. So how do you know if you have a performance problem? To be honest, most of the time, you don't. If you do have a performance problem, it's usually pretty apparent. Otherwise, right, if you have a performance problem but your app works fine, it's not really a problem. Until it becomes one, but it's not a huge problem. And you shouldn't optimize prematurely for problems you don't have. But if you do see it, the first sign of a performance problem is jank. And what jank, I guess the technical term for jank, the definition, is a perceptible pause in the smooth rendering of a software's application's user interface due to slow operations or poor interface design. Right? So if we see jank, if our stuff looks like it sucks, the first place that we want to go is DevTools. Right? Now, going into this, right, usually I build robot crossbows and drum machines, and I'm pretty sure not a lot of people have that much domain knowledge there. But coming here today, I didn't know how familiar people were with this particular panel here. If you feel comfortable in here, can I see a show of hands who feels comfortable in this panel? Alrighty, cool. I'll proceed with that knowledge. Yeah, so this is your performance tab, right? And that is the record button. And here is where you discover where the jank is coming from. This right here is gross. This is the worst case scenario. This isn't just jank. This is full main thread lockup. If we look at these arrows, right, that rascal up top, that's your frame rate. That when it's all green, and do I have a cursor? You see the cursor? Yeah, so this green right here, this is money. We're having a good time. And then right here, you've dropped to 0. Everything stopped. Not just animations, but all your interactivity. And what you're seeing down here is a long-running task, right? This is 2.5 seconds of main thread lockup where your animations stall, your users can't click buttons. It's a bad place to be, right? So 2.5 seconds obviously sucks, but what are the acceptable limits, right? Google has this thing called the rail performance model. Response, animation, idle, and load. I don't care about idle, and not that I don't care about load. We're just not going to talk about that today. But for response and animation, you have 16 milliseconds, right, which is an animation frame. So you have 16 milliseconds to do your business. And if you go over that, you drop animation frames. Now, if you're just doing like an update to something, right, you're generally all right with drop frames. The problem with actual like linear animations is that your user kind of knows where you're going with it, right? If this thing is animating over to here, right, there's a reasonable expectation that if it's moving at this speed, like sideways, and it stops and it's like, right, they can see that because they're expecting it to be here, right? So you have to be particularly careful with animations. As far as response, right, if somebody clicks something and you get feedback from clicking something, the rule here is 100 milliseconds, right? If you've ever seen the superhuman mail thing, they use this quote a lot, that every interaction should be faster than 100 milliseconds. It's the threshold where things feel instantaneous. There's a couple schools of thought here that it's 100 milliseconds. Other people say 50 milliseconds. But if you aim for that, your app will feel fast, right? If neither of those marks are on, right, how do we fix it, right? And the hard part about this, and largely runtime performance in general, is that unlike a lot of the advice you can give out about making your site, your service workers, all this and that, it's not super prescriptive, right? When you have a performance problem, it's like a puzzle that you have to figure out, and sometimes you have to get creative, and that's largely what I'm here to talk about today, right? And I have this thing called the I'm dope system. Really, just the bullet points lined up. But if you have a performance problem, right, you'll identify that it exists. And this is the most important part: measure your timings, right? You wanna measure these things not just to get an idea of how slow it is, but if you actually take down the actual measurements and then you improve them, then you have hard metrics, right? So if you go to your boss and you're like, hey, the problem's fixed, right? They're like, yeah, great, that's awesome. But if you come at them with like hard data, you're like, it is like 2.73 times faster, then I guess it's better from an individual marketing perspective. I don't know. Like, wow, you've really done it now, Wheeler. So after that, right, you're going to develop a plan based upon what the problem is. You develop a plan on how to solve it, and then from there you open DevTools and screw around and iterate and fix and measure and fix and measure until it's within an acceptable limit, and then you enjoy your newly performant app. So the most important part, measuring it, let's talk about that right now. So this is one of the most beautiful things in the entire world. This is an animation running at 60 frames per second. It's gorgeous. If you don't know what you're looking at right here, this is one frame, right? That's one animation frame, 16 milliseconds. And you can see down here, the work that we're doing is a very small part of that, right? This is very fast running. So it has room to do other things like handle user input, etc. If you look at it up close, this is what that little blip looks like, right? You have the animation frame fired. Our actual function call, which is the thing that we are doing, is 80 microseconds, which is lovely. That's a good place to be. And then you have some other browser stuff over here. So that can often be, I guess, hard to read. So there's this thing called user timing. Has anybody seen these things right here? Right? If you use React, right, you'll see these in your DevTools pretty often. And what that is it's an API that lets you define precise performance markings. And you can name them and display them in DevTools. And especially if you have some really complicated stuff going on, trying to track down what exactly is the problem is difficult. So using this lets you kind of isolate what you care about and measure specific things. Right here, right? Oh, geez. I thought I could click on it. Yeah, so you call performance.mark, and then you give it like a string name. And you do expensive things in here, or whatever you're necessarily measuring. And then here you do performance.mark main thread stop, and then performance.measure, and then give that a name, and the second and third arguments are the two marks. And then it'll show up there just like this, right in your timings. It says main thread right there. So if you want to measure specific things, it's super helpful. And React kind of has that built in for some things. So if you see the React ones with the little React emoji deal, that's what that is. And we'll show a little bit of that. So with that said, I want to talk about some common problems that you might have and the solution to those problems, right? With the caveat that there is no such thing as magic, and that again, there's nothing there. It's like, hey, this will just make my app fast, right? Let's do this everywhere. Everything has a trade-off. Every performance optimization you're going to make has some kind of trade-off. So you only want to use it when applicable, when you actually have a problem, and not prematurely optimize your app. So let's talk about React first. I guess that's appropriate, right? Yeah, so most of the performance problems I see with React are related to unnecessary rendering. And it's kind of wild how many people that I see, like when I'm working with people or interviewing people, things like that, that think that React somehow optimizes the renders, but it doesn't, right? If something changes in a parent, right, it's going to render everything unless told to do otherwise. So if you're having a performance problem, a lot of the time what you can do is control those renders. Now, one thing about React is it is not great when you have a lot of things rendering at the same time. And that's being nice about it. So you have to work around that. What helps with this is another level of DevTools here, which is like the best thing. This is the React DevTools profiler. Can I see a show of hands who actually uses this? Awesome. This is like the best thing. I work with a lot of people who either do like systems languages or they work in UI stuff that's not on the web. And they see this, I show them, I'm like, all right, let's just look into whatever the problem is. And I look and they're like, whoa, like your guys' DevTools stuff is out of control. And I'm like, yeah, come to think of it, it is. It's nice over here. So this is the profiler button right here. If you have it installed, you'll see it right there. And then you can hit this little record rascal over here. And then you can start interacting with your React app. And what it's going to do is it's going to keep track of all the things that rendered, why they rendered, all kinds of super useful information, right? So, famous last words, let's optimize the React app. Yeesh. Wait, can I go on my second screen? Do I have to get out of this? Jeez. I thought I could just swipe over. I guess not. Kenny's talk demos. All right. So here we have a React thing that doesn't really do much. It just renders a bunch of stupid tiles. You can click them on and off. And let's just take an initial look. Jeez. I might dock this. Boop. All right. So you can press this one to reload and start profiling if you want to get the initial render. So we can go boop and then hit stop. Right? So this is like the most annoying bar. Get that out of there and go to rank. And we can see each one of these tile things rendered. Just to see what we're actually doing here, I'll slide over to this. Boop. Yeah, so this is, how's font size here? Is it okay? Pretty good? Okay. Yeah, so here, right, we have our initial state where I do filthy array tricks to generate this bunch of tiles that is the state here. I have a tile component that'll render the tile. We also have a console log that'll say that it's rendered. Strangely, no lint error. And then here in our app, right, we kind of just render these out. We state.tiles.map, etc. And then when you click one, it's going to go through here and it's going to set that one active, right? We have our state with our use state. So let's head back over here for a second. So we look over here, and we see that this has rendered. And you see over here, once you click it, this is like the best thing ever. It says, why did this render? And it says, this is the first time this component rendered. That's fair. So if we start profiling again, and then we click something, boop, and then stop, right? So only one of these tiles changed. However, all of them re-rendered, and that sucks. Only the one that changed should render, right? So let's find out what happened here. All right, let's go through. Oh my goodness, hooks changed. Props changed. Jeez Louise, right? So it tells you prop change, on click, and children. All right, so let's see what's going on here. So one of the first things we can do here is for our tile component, we can wrap it with a memo, right? And this is your hooks equivalent of should component update or pure component, right? Where this will not re-render if your props or state has not changed. So we'll hit save, little hot reload action, blow. Do it again. They're still rendering. Wow. So this one, the prop changed active. That's valid. But on click and children also changed. The rest of these just on click and children changed. So let's see what's going on here. So here, right, we have this handle click business here. You have your on click prop that gets passed. These rascals right here. So one thing that we can do is in here and say, const click handler equals react use callback. Right, so this will memoize this callback here. Right? Wait. Yeah. Yeah, I think we're good. All right. All right. Let's see if that fixed it. I hate live coding so much. All right. Not fixed yet. Wait, unclick change? Well, that's BS. Oh, sorry. I'm dumb. We want to do it here because it's coming down from the top. So here I can say, well, we better update that or we're going to have a problem. Yep, we want to do it down here. So here we'll say click handler, right? And that's getting passed in. That calls that, right? Go back. Eating up the clock here. All right. It still changed, didn't it?
You need to provide a second argument. The second argument is callback.
What? What's the second argument? We're going to do this, aren't we? Gotta love those hooks, am I right? Yeah, hooks API reference. What do we have here? All right. Son of a bitch. Fucking. Oh, nobody knows how to fucking use hooks. Myself included. All right, so now children is the last one. So, this still kind of sucks, right? So, yeah, that does suck. So, we're going to have the children get recreated each time, right? Because we're passing in a child that gets JSX'd right there. So here I could do something, I could say like name is equal to tile.name, right? And then just boop, boop, come back up into tile here. And we can take name, children name. Take name out of there. Come here. Do a little P action. Name. Well, thought it would self-close. Now, that's what I'm talking about right there. Only the one changed. So if we go here and let's just do it from scratch here real quick. It does the first one, and then we do this. Right here, you can see there's two things right here. If I go to ranked again, right, this is our first one, right, which has them all on initial render. And then we come here on the click, right, and it's just because props changed active, right. So yeah, just to review what went there, right, we put a memo on our tile. Then when we passed in the click handler, we used a React use callback to cache and memoize this callback function here, which would otherwise get created every single time. And then we took the child of this and moved it right up into here. And now my stupid tile thing is performant. It's a good thing. God, fucking hooks. Okay. So, yeah, the next thing where you're going to see a lot of problems, right, are lists. So, as developers, almost everything that we do is building elaborate lists of shit. I'm not kidding. Think about it. Look at all the apps. Look at everything you work on. Look at all the apps on your phone. They're all just lists. Lists with, actions and things like that, but, they're just lists. So, lists can become a problem, right? This is a Ken Wheeler quote, is that generally speaking, they should be virtualized. What'll happen is, if you have a list where you know how long it is, right, and it's not that long, you're good to go, right? But if you're getting a list and populating it from the server, right, a lot of time you said, oh, it'll never be 20,000 things, and then they put it onto prod data, and boom, it's 20,000 things. And they're like, why is this slow, man? So, get ahead of that. What virtualization is and thank Adi Osmani for the sick graphics, because I wasn't going to make this myself. You have this little window right here, and what it does is it says, if you have a really long list of things, right, only render the shit that's inside of that window, right? Easy enough, right? So it does suck from time to time, and I'll tell you why. Certain virtualized implementations, right, you can't Control F search it. That's something I'm dealing with now, right? If somebody's searching on the page, right? If it doesn't exist, if it's not rendered, right, your Control F in your browser isn't going to find it. So, you do what any developer worth their salt does and override Control F in the browser and write a custom find, because that always works out best, right? They also introduce challenges to accessibility, which sucks. You can work around it sometimes if you do the right key bindings on it. Or, regressively dehance? I don't fucking know. Also, sometimes if you have heavy rendering in your list, if your list is super fancy, sometimes it'll show flashing if your rendering can't keep up with the windowing, right? So if you want to virtualize your list to make them better, you can use things. This is my personal favorite right now, which is React Window by the lovely Brian Vaughan. He also wrote React Virtualized, which gives you a little bit more, right, if you're trying to do a grid or a data table kind of thing. There's also Iron List if you're one of those folks that uses web components. So let's take a look at how lists go. Close this tab of shame. Yep. All right. So this is a regular ass list, right? If we go look at the code for this, it's nothing special, right? In here, I just generate 10,000 list items, and then here, I just dump them into the DOM, right? If we want to look at some profiling here, we can take a look, right? Right. Not too bad, right? It's a little crappy on the first render, but not super bad, right? The problem is when you do it in React, right? So if you do this in React, it becomes horrible because each one is wrapped to the React component and then gets processed by the reconciler. Whoop, hold on. Let's do a refresh one here. Wowee. Absolutely heinous. Gross. Gross. How long did that take? These are the user timings, by the way. Right, the list mounts. Takes 334 milliseconds. So let's look at some interactivity here. I want to hit that. Look. See it frees everything up, right? If you want to reverse that list and then reconcile that in React. Well, not that one. Come here. Wow. So this is our actual interaction right here, and it's committing host effects, 10,000 total. That's gross, and you don't want to do that. So I'll show you virtualized here, right? I'm going to use React window for this demo. If you come in here, you import your list from React window. We have our same thing right here. It's pretty straightforward. You have this list component. You have to give it a height and a width and an item size. And then the children are kind of like a function, but you can kind of just give it a component because of hooks. So here I can have row. I call memo on it. You get index, style, and data. Style gives it like the absolute positioning that'll put it where it needs to be. And then I can say for my data, right, which is list items, the index of that data that I want to render, right? So that's the array index. So if we head back and go to the virtualized edition, check out how blazing fast that is. Wowee. And it just scrolls perfect. It's pretty fast too. Like if you don't, there's not too much glitching. Like if you had a bunch of stuff in here that took a while to render, you might see a little bit of glitching, but it's a pretty simple list. So go check out our performance metrics here. Whoop. Boop. And that's much better, right? I don't see any red at all. Yeah, so that's list virtualization. 12 minutes to make it count. Okay, wait. Desktops, Jesus. Okay, so the next thing I want to talk about is CPU intensive tasks. From time to time, you might have to do something kind of heavy in the browser, right? Unfortunately, all of our code runs on the main thread, and that's where your UI usually runs. So that sucks. Because if you do anything that's CPU intensive and you lock up that main thread, like we did initially, everything stops. The way to fix that is with web workers. Can I see a show of hands who actually uses web workers? Not enough, because web workers are like the best thing. Seriously, they're amazing, right? I've solved a lot of performance issues with web workers because they create a thread, right? It's a background thread for the web where your code can run off of the main thread, freeing that up to do the important UI work. The problem with them, I guess, why you might not run to it for every problem, is that talking to it back and forth, right? You have to serialize whatever you're sending over. So there's cases where that's not worth it, right? It just doesn't make sense. If you wanted to create one, right, you would have this, you create like a worker.js, and then you say worker equals new worker. You set up a listener here, for the on message. So you say when it gets a message, when it sends a message to the main JavaScript, just console log that. And then here, I send a message to it. I say, go do stuff. And then in worker, right, there's the listener here for on message. And when this gets this message, it sends a message back, right? So you toss in a potato around here. And eventually this will render it did stuff. But I guess the point of this is that it executes on a background thread. And I'll show you a cool example of that. So if we look at our code here, all right, I have some Canvas stuff going on here. Right? There's going to be a box that's doing something here. And then in here, so we have the main thread button. So in here, I want to call this calculate primes method for the main thread button, which is going to run an expensive thing. Over here, I'm going to have it in a worker, and we're just going to send a post message to that worker. If we look at the worker here, I'm doing the same thing that I was doing, this time just in the worker. So if we head over here and go to our worker demo, this is a beautiful 60 frames per second animation. When I hit the main thread, everything stops. Stops it. So sad. But when you do it in a worker, it keeps going. You keep clicking it. You click it a billion times. Nobody cares. It's fine. Your stuff's all set. Right? So, if you have a heavy CPU task, you can do that there. If you have non-network long-running tasks or non-network, it's a lot of the time, right? If you click a button and your response isn't fast enough, right? A lot of the time that's the server. If it's not the server, if it's your actual code, you're actually doing computation. How do we make that faster? If we can't, if our JavaScript isn't fast enough, how do we make it faster? By not writing JavaScript. By writing WASM. So WASM's a funny one. It's an open standard that defines a portable binary code format for executable programs, right? Despite it being called WebAssembly, right? It's not really web. I mean, it runs on the web, but it's its own thing. And what it is, it's a compilation target for things like C, C++, Rust, a couple different languages, where you can do some wild stuff on the web with. And if you're doing really computationally heavy things, you can do it in WASM. The downsides are, it has to be worth it, right? Like, you're not just going to add two numbers together with WASM. Then JavaScript's going to be faster. But if you're like putting an Xbox game in the browser, not only is it faster than JavaScript, JavaScript couldn't do it, right? It makes that possible. Just like workers, right? You have the serialization communication problem, right, where it's slow. Also, it's a nightmare to debug. It's gross. But let's check it out. Whoop. Come back over here. I'll just show you what I did here real quick. So in here, I have a similar kind of setup where we have this main button and this WASM button. I use performance marks because there's not really UI involved here. So here, I just do some stupid thing where I reduce like a million things in an array. And in WASM, I essentially do the same thing, but just in Rust here. So I have index.rs. You might say, how do I just have Rust just chilling in this folder and it works? I'm using Parcel. So if you use Parcel, you can come on over here and just import from your Rust file, and it'll compile it to WASM, and it's usable. It's not usually this simple. Sometimes it's a little bit tougher. If you have it actually doing anything other than numbers, you have to go through a pretty complicated setup. But let's take a look at our performance marks and see what the difference is. All right, so I'm going to come here. We're going to record. I'm going to hit the main thread. Then I'm going to hit WASM. Then we can take a look. Right? So they essentially do the same thing, but if we look at our timings, right, to reduce a million things in regular JavaScript on the main thread, that is going to be 27 milliseconds, which is big, and it'll cause you to drop a frame. You got to use the marks because they're little rascals. They're hard to find. Yeah, so the WASM one took 55 microseconds to run. So if you want to, I mean, this is an incredibly contrived example. If I make it in time, I have a better example of using WASM for something fun. But it's an option. All right. So the other thing I wanted to talk about was jank protection, right? So you saw we had our canvas, and then we went and put something in a web worker. But you don't always get to control that. Right? You're not always in a position where the thing that you're working on, you own the whole Chrome of everything, right? So if you say, hey, I have this this time-sensitive thing, right? I have something that is uninterruptible, right? It either needs to animate or it needs to be shown at like financial data or something, where like if you wait and the timing's off, lose $1 billion or what have you. You want to make uninterruptible UI, right? So if that UI itself is a candidate for being displayed in a canvas, I have the coolest thing in the world for you, and that is off-screen canvas. Can I see a show of hands who's heard of off-screen canvas? All right, off-screen canvas is the jam. All right, so it's a canvas that can be drawn off the main screen, right? More importantly, off thread and in a worker. And it lets you create threaded, uninterruptible UI. It's essentially UI threading. It doesn't work with the DOM, but if you're doing canvas stuff, you can thread your UI. It has all the drawbacks of regular canvas, like accessibility problems. It's a little new, so browser support, and it glitches a little sometimes. But it's pretty incredible. All right, I'm going to show you the demo real quick. Boop, boop. All right. So we've got these two little rascals jumping up and down, having fun. Right? So in here, here's where the magic happens. I have off-screen canvas right here, and then I have my canvas, and I transfer control to off-screen. So with your canvas, you transfer control to off-screen, and then I created a worker here, worker.js, and then I post message this canvas, right, which the second array is transferables, right? So it sends this instance of off-screen canvas to my worker. Inside of my worker, right, I have this on request animation frame, just drawing. So I'm just sending it the canvas, and I set the canvas in scope using that message. Back over here, right, we have this event listener where we do the same thing, where we calculate the primes on 80 billion things. So this rascal on the left is a regular canvas. The guy on the right is the off-screen canvas. So no matter what's happening on your main thread, this one keeps going. It's like a little chunk of your screen that just operates independently. So for certain performance problems and challenging UI problems, this is a candidate to get it done. All right. Oh no, it's time for the fun demo. Okay. Hopefully this works. You just carry a lavalier mic around with me all the time. What is that? Oh shit, that's the headphone thing. Like with the Bose headphones, it has like the special little wire. It's missing, it's found. It was wrapped up on this rascal. Okay, yeah, so I have like 2 minutes, so hopefully you can make this work. Okay, that'll work. Where is this? Auto-tune. Okay. So before I was talking about how that WASM example is kind of bullshit, but there are really cool things that you can do with WASM that make it worth it, and I wanted to show you one of them that I did, which is as silly as can be. And what it is I took an auto-tune library that was written in C, and then I used mscripten, right? What mscripten does is it will take, is this on? Yeah. It takes anything that can be compiled with LLVM, and it'll compile it to WASM, right? So I can take this C code here, right? And then I can compile that down to WASM and run it in our browser. Thankfully, Google provided this lovely ring buffer worklet processor. So we're running this in an audio worklet, and what it lets you do is process on a worker thread with WASM a stream of audio, right? The problem is that this thing has a buffer, right, which is how much is like processed at a given time. I think it was like 2048 or something, and the audio worklet is 128, I think. So you need this to translate the two. So I am running out of time, so let's check this out. Hopefully this works. Yo, 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 yo. One more time, we're gonna celebrate. Oh yeah, all right. It's fucking crazy, right? Right, and you could just import the module right here, the WASM module. Right, you come in here, doop, 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 and this is your actual processing method here. So on the web, in a worklet, in an audio worklet, it goes here, and it will actually process this right then and there, right? You have this kernel process, right? That's how it goes through. But that shit barely works on some computers, and here it is working on the web. So WASM sick, you should check it out. That's all I have on performance. Thanks so much for listening to me read the track docs.